Today's lesson is a continuation of section 3.4, solving equations with variables on both sides, or like I mentioned in the last lesson, I call these VOBs, V-O-B-S, because again, it's just an acronym that stands for variables on both sides, so VOBs. So if I say, I know I give out the worksheets and I say VOBs number 1 or VOBs number 2. Those are the worksheets that are referring to this particular section where there's variables on both sides of the problem. As I talked about last time, when we first started this section, even in these problems, and in all the first 4 sections in this chapter, section 3.1, 3.2, 3.3, and 3.4, in all those problems, you can still use this same set of 3 steps when I'm solving any kind of multi-step equation. I think these steps will get you through any type of problem, no matter how complicated it is, at least at the linear level. And again, sometimes there's different ways you can go through one of these problems, or you can do the steps in a little different order. But this is the order that I recommend because you'll run into the least glitches, the least moments where all of a sudden it's like, oh, what do I do at this point? If you always follow these 3 steps, the step is always going to take you to something familiar, to the next step, and then the next step, and then we get to a point where we're always at a 2-step equation, and then I can solve from there. So I think this step is a nice, clean path, an easy way to get to the answer, so in my opinion. And again, today we'll focus a little more on maybe when we have to do steps 1 or 2. The first day of this section in 3.4, most of the time we didn't have to do much in terms of the first 2 steps, distributing or collecting like terms. But now today on some of the problems we'll have to do those things. And then again, this section concentrates on step 3, which we hadn't talked about as much before, but now we will, getting the variable on one side when we need to do something like that. So I'm going to look at this first example. It's example number 5, it says here. Again, the problem says solve. Directions say solve, so that means find out what the variable stands for. We're trying to get g by itself. We're going to end up with something like g equals, and then some number on the other side. So that's what we're trying to do. Anytime you're trying to solve an equation, again, I will refer you to these steps, especially multi-step equations, but I will refer you to these steps. And these are the ways that I'm always going to solve the problems and ways I've grown up solving them, and they do work. As you can tell, I believe that these problems, these steps will get you to the answer most of the time, as long as you follow the correct steps, obviously. And I will, as I've talked to the students in class, I said sometimes it's easy to get frustrated on these problems just because there are so many steps. And sometimes you make just a small mistake and that can throw your answer off. Okay. Obviously, it is kind of a process. Sometimes there's 3 steps, 4 steps, 5 steps. But as I mostly have walked through the classes and usually see that most kids are doing the steps right, but every once in a while you make a small mistake here or there. Don't get frustrated, because again, a lot of the times we're doing a lot of the steps right. And again, here are the steps that I would recommend you follow. Distribute, collect like terms, get the variable on one side, and then solve. So in this first problem here, again, that's what I'm going to look to do. Number 5, it says negative 16 plus 7g plus 3g equals 4g plus 10 plus 8. Okay, so I have kind of a big mess there. But again, no matter what the problem looks like, go back to your steps. Here's what I want you to do. First, look, is there anywhere to distribute in this problem? Well, in this problem, I don't see anything with parentheses on either of the 2 sides. So no, now I have to do step 1. There's nowhere to distribute. That'll help me. Step 2 says collect like terms. So now I'm on the step. Step 2, collect like terms. And what I'm talking about there is, can I collect like terms just on each particular side? So look at this left side, just this side here. Is there anywhere to collect some like terms? Well, yeah, I see there's a 7g here and a 3g here, so that's what I'm talking about. I'm going to add those 2 terms together. So I'm going to have negative 16, and then 7g plus 3g is going to give me 10g, so plus 10g so far now. Equals, well, now I'm going to look at this side. Are there anywhere to collect like terms on the right side? So when it says distribute or when it says to collect like terms, it just means look at each individual side. And sometimes you might have to do it for both sides, or maybe just one. But that's what I'm talking about. Look at that side and see what do you have to do. Can you do those particular things? On this side, I have 10 and 8. They're just constants, but I can collect those. So I'll have 4g plus, and then 18. So again, on both sides, I was able to collect like terms. Now we're on to step 3. And again, this is one we've concentrated on a little more lately. Get the variable on one side. I have negative 16 plus 10g equals 4g plus 18. So I'm going to try to, as we talked about in the previous lesson, I'm going to try to eliminate the variables on one side because that'll move them all to the opposite side. So in this case, I'm going to say I'm going to subtract 4g is what I'm going to do on this particular problem. And again, I actually showed in the previous lesson, if you want to go back and look, you can actually do it either way. You could subtract 10g from both sides if you wanted. and there'd still be a way you could still get the same answer as your neighbor, regardless of which way you would do it. But in this particular problem, I'm going to subtract 4g from both sides, just because I like to keep the variable positive in my problems, just to make it usually a little simpler and a little less science to deal with often. So if I subtract 4g on the right side here, okay, 4g minus 4g just gets rid. This would give me 0g. I wouldn't have any of them. Okay, and again, I don't have to put 0 because that means just there's none of them there. I bring down this 18, so that's all that's left on the right side. On the other side, I still have negative 16, and now 10g plus 4 gives me 6g. I've got the variable all on one side now. That's what I want. And again, once you get through those first 3 steps like that, this last part, use inverse operations, is usually just when we're at a 2-step problem, which, again, you've done many of in the past. So if I'm solving this 2-step problem, I got to get g by itself. So I have this negative 16 out front here. I'm going to add 16 to both sides. That gets rid of the 16s out front here. 6g equals, well, I get 34, it looks like. And divide both sides by 6. And g equals, what, 5.6 repeating, I think. Because, yeah, 4 out of 6, yeah, 5.6 repeating. And again, every once in a while you will get a decimal. That's okay, that can happen. Usually I try to make the answers so that they're integer answers, but every once in a while we get a decimal. I think we followed all the correct steps, so that's what I get for that first problem. Just going to walk us through another example or two here, just again, so we get the idea, but this section or today's lesson is a lot like the previous time we went through this section 3.4. So again, just kind of following through our steps and making sure we go, okay, distribute first, collect like terms, and then again in this section try to get the variable on one side. But I'll walk through a couple more examples here just to make sure we got the idea. In this next problem here, it says number 7, negative 6p minus 27 equals 5 times in parentheses 2p plus 1. So again, I'm solving some kind of multi-step equation. I think if you follow these steps, it'll get you to the answer in a logical and in a way that is usually one of the simpler routes to get to the answer. So again, the first thing I'm going to look to do, well, is can I distribute? Can I distribute anywhere in this problem, on the left side or right side? And actually on the right side, yes, here I can in this case. Okay, I can take 5 times 2p and 5 times 1. So what will I get in that case? 5 times 2p gives me 10p. 5 times 1 just gives me 5. So on the right side, I have 10p plus 5. On the other side, I still have negative 6p minus 27. So I just bring that stuff down to my next line. And I've taken care of step 1. Now I look on each side, again, looking at step 2. I say to myself, well, can I collect any like terms on each of the 2 sides? So on this left side, no, I got negative 6p and minus 27. That's a term with a variable and a constant. I can't collect those. 10p plus 5, nope, I can't collect either of those either. So nowhere to collect any like terms in this one. So now I'm just on to step 3. Get the variable on one side like we're working on, and then use inverse operations to isolate. So getting the variable on one side, in this case again, you can do it either way. I'm just going to think about trying to eliminate the variable on one of the sides. So if this is negative 6p over here, in this case I'm going to add 6p in this problem. That's what I'm going to try to do. When I have negative 6p plus 6p on the left side, those cancel out, so those are gone. And again, this 27, it's got a subtraction sign in front of it. I could chop dash it if I want, but just think of that like negative 27. So that's what's left on the left side. On the right side, 10p plus 6p gives me 16p. And then plus 5, so here's what I've got so far. And now this is just a 2-step problem. I'm going to do 2 different steps. I'm going to have my answer. So again, problems like we've seen many times before. So in this case, I'm going to subtract 5 from both sides. When I subtract 5 from both sides, on the left I get negative 32. On the right, I still just have 16p. Divide both sides by 16. I'm just kind of bringing my answer over here. I get p equals negative 2. And I'll go through one more problem here together with us, and this one has a little bit of everything, so that's why it's probably a good problem to go through. And again, as you'll see on a problem like this, well, there's a bunch of different steps to get to the answer. But notice all the steps, I mean, if you just kind of take them one at a time, the steps themselves aren't too tricky. They're all things that we have worked on, especially now that we've incorporated this new section, 3.4, how to deal with the variables on both sides. So again, any multi-step problem, now I imagine that students could have a chance of solving, and have a very good chance of solving, because we've seen all the different types of things that could happen to us up to this point. So if we just follow those steps, go through them one at a time, and take our time with the problem and show our work, and we got a good chance of getting to the answer. In this first problem, so again, I'm going to think about my steps, or in this last problem here, I'm going to think about my steps. It's problem number 8. It says -2, and then parentheses x plus 4, and that equals 6x minus 31 plus 7. Thinking about my steps, step number 1 says distribute somewhere if I can. So over on this left side here, I can take -2 times x and -2 times 4. So yes, I can distribute in this problem. -2 times x gives me -2x, and -2 times 4 gives me -8. Which is again just kind of like -8. I haven't done anything with this side yet, so I'm just going to recopy it. But that's what I've got so far. I've distributed. Good, I've taken care of step number 1. That's done. Step number 2, as you remember, is collect like terms. If I look at the left side, I know where to collect like terms over there. On the right side, though, I do have some like terms I can collect. -31 and 7, I can collect those terms and put them together, those two constants. Let's see, I'll get 6x, and then -31 plus 7 gives me -24, or again, like -24. That's how I can write that in my problem. On this side, I still have -2x minus 8, so far so good. I've taken care of step number 2. Last step, step number 3. Get the variable on one side and use inverse operations to solve. Again, I like when my variable is positive. So this has -2x over here. In this problem, I'm going to eliminate that from this side. I'm going to add 2x to both sides. That'll keep my variable term positive. So if I add 2x to both sides, that gets rid of it on the left side here. Now I have -8 equals. Well, over here I have 8x minus 24. And once I've done that, now I'm just down to a 2-step problem. Add 24 to both sides. I always like to add or subtract something first at this step. So in this case, I'm going to add 24 to both sides. That'll get rid of the 24s. Now I got 8x on this side. On the other side, I have 16. Divide both sides by 8. X equals 2. Again, that problem had a little bit of everything. A little bit of distribute, collect like terms. I had to get the variable on one side. But again, then I was just left with a 2-step problem. Every one of those steps, things we've worked on so far, every one of those steps, things that I think you can do. So, but you just got to kind of take your time, show the work, go through the steps. And more often than not, I believe we can get to the right answer.